Hello, 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 everyone, and welcome to our April meetup. I am Kaya Imani. I'm Deborah here at LocalStack. We've got people joining from all over the world right now, which is actually pretty wild to think about. So wherever you are in the world, whether you're mid-work day, just waking up, pretending to work, I'm glad you're here. You could be doing anything else right now, but you're here with us, and I am grateful. So let me ask you this real quick. If you ever had your test pass, CI is green, everything looks beautiful, and then you deploy, and suddenly your app is acting brand new, like totally different app. You know how that goes. Today's session is for everyone who's ever been betrayed by their own test suite. Okay, so before we get started, quick vibe check. You can drop your questions in the chat as we go. Don't be shy. We really like the interactive sessions. We'll pause at the end for Q&A, but honestly, if something comes at you mid-talk, just throw it in there. This is being recorded, so if you need to rewatch and be like, hey, this is what I've been saying the whole time, you'll be able to go back and do that. And if you are not in the LocalStack chat in our Slack, that's where the real conversations happen. You need to be there. We'll put, there we go. QR code, scan it, get in the Slack. Folks are breaking things, fixing them, breaking them again, real dev activities. Okay, so let's get into it. Today, we are going to hear about testing your cloud like you mean it and integrating test containers with LocalStack. I'm really excited to introduce our speaker today. We're actually only having one speaker. We've got John Nguyen from E.ON. John's
Yes.
that was correct? Got
Yes.
it. Awesome. John's one of those type of engineers who don't just stay in one lane. He started in PHP, moved to front end, and fell into JavaScript, kind of like the rest of us. So he's seen these problems from multiple angles, so it's not just theory. John, I'd like to hand it over to you to do a quick intro, and then we can get started. How about that?
Yeah. Thanks, Kaya, for having me. And I've been following LocalStack from version 1, I would say. Sometimes a bit more, sometimes a bit less. Recently, I got into LocalStack a bit more because we have in our company this problem about how to test your AWS services, like particular like serverless applications such as Lambda, SQS, and so on. And it came up from my side that we could use integrate LocalStack into just to build some confidence around it. I'm based in Berlin. I also have a slide for later to introduce myself a bit more.
Okay,
Yeah, but as
awesome. Well, in that
Kaya
case,
already mentioned. Oh, sorry.
sorry, that's how it goes with these Zoom meetings, right? I mean, of course, that's like the virtual meeting dilemma because we all talk at the same time. So sorry about that. I will let you start sharing your screen so that you can kind of get into the intro and get into the meat and potatoes of your presentation, if that works for you.
Yes, it does.
Awesome. Let's do that.
Yeah. Thank you again. And this time it's all about integration testing, how to use Testcontainer, which is a testing library, and LocalStack to test against your AWS environment. But I'm not alone. I am actually here with someone I would like to introduce you. His name is Paul. It's a little dog. He follows me, and as every dog, you kind of want to give him tricks, or you want to teach him lessons and how he or she should behave. I will, because it's a he, I will give him the pronoun he. And Paul is actually something. It's kind of like a repository which I created, and I named it Paul, and it stands for Professional AWS Library. Because what I, as a software engineer, are facing nowadays, or like in the last 8 years, 8 to 10 years, that we as a software engineer, we do not want to reinvent the wheel all the time. Yeah, there are like software engineering patterns or design patterns you probably have heard of, and yeah, the aim of Paul is that he that he gives you some reusable components. This is what I call it, and you can. It also concludes best practices and, so to say, pattern. And nowadays, when we use AWS or infrastructure as code, there are a lot of abstractions. So let's, for example, using AWS SAM, it's an abstraction layer on top of CloudFormation. Or my favorite tool is AWS CDK, which is using programming languages on top of CloudFormation. CloudFormation itself is very declarative. Why not using something like a higher level programming language to even abstract it? And with that, you can also apply some design patterns on it, or best practices, or any kind of pattern. What I also trained Paul to is the improved developer experience. So I am a big fan of TypeScript, and what TypeScript can give you is some autocompletion or some types which you can define, which makes you creating components or creating constructs to be in terms to be term compliant with the AWS CDK library, to create powerful constructs where you have, which are fully typed and where you can not really make mistakes because they are fully typed and you cannot really put like rubbish or instead of a string a number and so on. So this is also what I taught Paul to improve the DX here. For now, it's just as a CDK library, construct library, because what I also saw is whenever I started a project, when we use CDK, we created a construct library because the Lambda functions, I will show you an example. So we want to simplify the DX. So whenever I start a project, there's this construct called Node.js function coming from the CDK lib, and we always create an extra construct to wrap this. Like we want to have ARM64 for efficiency. We want to use the latest Node.js version. We also want to keep the Lambda as minimal as possible. So we minify it. We only want to use ESM. We want to make sure that the tree shaking, that the Lambda is basically small. But we don't want to copy paste this all the time, every time we create a Lambda function. So that's why we always create a construct library. And instead of having this property, which then looks our code base ugly because it's huge, we could simplify it by just simply saying, okay, all the best practices are coming from this construct called lambda function, and we only pass it the entry point, which is in this case the SQS demo handler. So your lambda handler. And this pattern I saw over and over again. That's why I was creating Paul, or that's why Paul exists. What we also could do is we could define properties. So when creating construct, we can say, okay, this SQS has two mandatory properties, which is a lambda function, because when we send a message to SQS queue, a lambda should pick it up and process it, do whatever. And we also enforce the user to say, okay, want also to have a retry mechanism. CDK has like something inbuilt, but we can force the user by saying, hey, put a retry number in here so that it retries if it's failing. We can still give the option to say, okay, we want to also give the option that it's a FIFO queue or a normal queue. So we can also say, okay, you have the option to put a Boolean in here. We can also omit properties from the CDK library. We can say, actually in our company, we have like a naming convention. I don't like that the developer is adding their own naming in here. So we can say, actually, let's remove the queue name here and make sure that our construct is using the naming convention following the company compliance or whatever. And we can also say, you know what? You don't need to worry about the dead letter queue, but the construct will take care of the dead letter queue. So I am the owner of Paul, and I'm a software engineer at E.ON. My name is John, and I have been working in the web industry for about 10 years now. A bit over 10 years, and I have been doing various jobs from DevOps to cloud, but always using TypeScript or JavaScript back then. As Kaya mentioned, I started with PHP. I'm based in Berlin, in Germany. And one fun fact about me, I do code showers every day, regardless of the weather, unless it's super cold outside, and I have been outside for hours, and I have to shower afterwards. Then I don't do code showers, or I'm sick, then I don't do it. So as for any dog who wants to learn trick, he will need some tooling in order to improve. And in this case, Paul fits really along with LocalStack and Testcontainer. So since it's the LocalStack meetup, I was thinking, okay, maybe I don't need to introduce what LocalStack is, but Testcontainers is maybe not familiar to everyone yet. So what Testcontainers is a library to wrap real services into a Docker container. What does it mean? So usually when we use AWS, if you're working in a corporate environment, you're probably just creating microservices. So you are just a wheel in the bigger picture. And any application can be wrapped into a Docker container, right? So it could be the database. LocalStack can also be run in a Docker container. And these containers or services which we wrap into a container, we can then do integration tests with it. So as I mentioned, you can test against a real database. It does not have to be production data, but it is a real Postgres database, which your production service also work with or do the CRUD. You can also run it against message brokers such Kafka or SQS or any other cloud services. It doesn't have to be AWS. Testcontainers has the possibility to wrap every service you would like to into a container, and then it provides you an isolated infrastructure on demand, so you can make sure that everything stays within that infrastructure. That means it can also not just run locally, but also in your CI/CD. Now you can ask, okay, now you can question why not using Docker Compose instead of test container. Well, let's say you are working on multiple microservices and they all use the Postgres database. Yeah, Postgres database is running per default on 5, 4, 3, 2. And then if every microservice is using the same Postgres database for the same port with the same port, then of course you run into port conflict. That's why a test container really provides you an isolated infrastructure by providing you a different port. And the goal is to ship with high confidence. Just as a quick how it works, so you still need to define your test case here, and then test container makes sure that the container is running, and then after that performs the test against the running container. So in this case, it's running against the Postgres database, and then once the tests are finished, it doesn't matter if it passes or failing. It will automatically remove the container, so you can be sure that there will no port conflicts whatsoever. Yeah, that's why Paul, LocalStack, and Testcontainer harmonizes, because Paul is a construct library now just for CDK. We can test the constructs running against LocalStack, and we can run integration tests using Testcontainer. There is this modules page coming from Testcontainer. So if you search for Testcontainers, you will also have this modules page, and there you have categories coming using relational database. So yeah, Maria, MySQL, Postgres is here, but you also have like cloud, and there you have LocalStack, which is an official module provided, or there is an official module when using test containers. And as you can see, there are modules, LocalStack modules for various programming languages or runtimes. And today we will focus on Node.js, and we will see it now in action. Maybe just quickly maybe sorry about that. Maybe regarding Paul. So this is the library of Paul, and yeah, Paul is basically a monorepo which has a battery included monitoring and observability, So it also has like a package called for Lambda handlers. So the Lambda handlers are typed and are using power tools out of the box. You will also see that in action. And yeah, so the constructs are coming from this Paul CDK package, and there you can, as you saw earlier, define the Lambda function, and you can also connect, because Lambda always needs an event to be triggered. In this case, it's API gateway, which you can chain together, and then the Lambda function. I use the use statement, so I got a bit inspired by React in this case, where where the function is coming from the Lambda package is called use API handler. So I know in this case this Lambda function is using the API handler, and then all the events here in the loggers are fully typed. Okay. So there's also a CLI. The CLI supposed to scaffold you a project. This project usually comes with the source, where I put the Lambda handler in here, and where you also put in the stacks folder, where you put the stacks here, and then the test case. It's a CDK project, and there's also something like called local def, where I have a method called define stacks, because what the index here does is it reads through the stacks folder and deploys everything which is inside the stacks folder. So if you have multiple stacks, then it will always bootstrap these against local stack. So that's why I created something like this local def, where you can define locally against local stack what stack you actually want to test with, because you don't want to deploy all the stacks. For now, it's quite simple. So let's do some live coding. And I have now in the stacks. So this, I have what I want to do is, so I want to send a message to a queue, and then the message will be picked up from a Lambda function. So what I do is I create a queue, or I will create a queue and the Lambda function. And if you have been using CDK, you have to define a stack, and you also have this concept of construct. Not a big fan of this, but for now, let's stick to that. So I name it LocalStack demo stack, and this will extend the stack. And Copilot is suggesting me how it looks like. The pattern stays the same, even though it's coming from the Paul CDK, but the pattern, how I define a stack, stays the same as when using CDK. And let's do like this. And then I want to create a new SQS. And since we are in this scope, demo queue, I will give it an ID called demo queue. And since everything is fully typed, now my LSP is complaining that it's expecting 3 arguments, but I just provided 2. And the third argument is like an object where you can provide properties. So in this case, yeah, I have a bunch of properties I can pass in here. For now, you can see that 2 are mandatory, the fn, which is a Lambda function, which expect a Lambda function. And there's also retry, which is a lambda. So in this case, I say let's retry twice. And the lambda function we have to define. So this is what we're going to do now. We can say lambda, a new lambda function. We are on this scope. I would call it LocalStack. I would call it LocalStack lambda. And as a third argument, I also have the properties, an object I can pass in here, the entry property. And I want to use, if you look on the code tree here on the left side, I have already a lambda function. It's called SQS demo handler. And you see also below here, there's something like utilities TS. So if I open that, it's simply like a helper function which identifies the path of the folder where the lambdas are put in. So I will make use of that by importing this function, and then it's called lambda source, and this handler is called lambda demo SQS demo handler. And I have to import this, and then it's complaining that fn is not having a lambda function, so I add it here. And IAM is also complaining. Okay, and now we have our demo stack, which is where we created an SQS queue, and the lambda picks up the message. Just to show you how this works with the lambda package. So when I import, I can import from the Paul lambda package. So if I want to import the function here, so there are some options. So in this case, I know it's going to be an SQS handler. So I import that function. And I have to export this handler, like naming it also handler. This is like a bit opinionated from my side, but for now it is like this. And what the handler expects two parameters. So the first parameter is the service name. So I can name it demo queue. And then the second parameter is an async method, which expects an event. And you can also get a logger from it. And as you can see, my LSP recognized that this event is an SQS event. So when I do something like event, let me disable Copilot. Copilot disable. Okay. So if I now use the event and do dot on it, I see there's a record, and there, if I take the first element, I get all the properties coming from this event. So again, the lambda handler is picking up the message, and since the handler knows that it's receiving an SQS event, it gets all the property an SQS event would send to this lambda. Okay, let's do also make use of the logger. So in the background, it uses the power tools. What we do here is simply just lock the body. Okay, that's now enough for setting it up using Paul. Now, the more interesting part is the test containers. So as I said, already mentioned, we are using the test containers, the module LocalStack from the test container, and it has only two classes here: the LocalStack container and the started LocalStack container. And before we in the test suite, so everything is in bun. So in bun, the tests are written like in jest or in vtest, or even Node has some inbuilt testing suite. So when you define the suite, I have to define 3 variables: LocalStack, the endpoint, and the environment variables. The environment variables are AWS specific configuration for LocalStack. And the endpoint is coming from test container because it spins up a container for you, and then you also get the endpoint with the random port number. And you can also define, and I also put here something configurable so that you can also pass a LocalStack image. If you don't pass a LocalStack image, it will take the community archive in this case. And the next following step is a bit more complicated, and I had to ask Claude, or what was it, Codex, AI, to help me here with this. Because when I create the LocalStack container, it expects an image. So the string should be really the same string coming like in the Docker Hub, or which you find in the Docker Hub. And I have to tell explicitly, please use my Docker here. Usually it takes Docker per default, but in my case, I don't know why, I had to explicitly add this to my test environment so that it knows, okay, it uses Docker. So you could also use Podman, I believe. I haven't tried it out, or whatever alternatives to Docker are out there. So once we create the LocalStack container, we start it, and then we have access to the ID, we have access to the URI, and since we have the access to the URI or URL, we can actually also extract the port from it. And in LocalStack, you also have to define an S3 endpoints, I believe, for all the assets in here. And this you put into the environment variables where you have to define like the default region, a dummy access key, a dummy secret key, and the endpoint URL, so that your CDK AWS CLI is running against that endpoints, against LocalStack, basically. And then we also add the S3 endpoint in here. This is something which, because for the API gateway, I used the version 2, and LocalStack does not support version API gateway version 2 unless you buy a license. So I came up with this local, so that it will run against API gateway version 1, so that you can still test your Lambda, but in that case, testing it against the REST API gateway instead of HTTP gateway. And then you have, because before CDK apps works, you have to bootstrap it. So you have to run the bootstrap here. There is also a package from LocalStack called CDK local, which basically runs CDK against the local instead of against your AWS environment. And so I have to bootstrap it. I also give it some context here. And as you can see, I run it against the local dev TS. So instead of running using the index, which is defined here, I said, okay, let's run it against the local dev. Otherwise, it would deploy all the stacks which you may not want to test. So you have to bootstrap it, and you pass in the environment variables here, so all the AWS related secrets and so on. And then you also deploy this. In this case, we just created a LocalStack demo stack, LocalStack demo stack. Yeah, I hard coded it, but in the future it should be like picking it up dynamically. Okay, and I had to put a long value here. This is like the timeout. Otherwise, the timeout would be 5 seconds. And if you are not having the image yet fetched or pulled, then 5 seconds is not enough. Yeah, and after that, you delete the local stack, so you clean up a bit. Okay, I hope you can see that. So what we want to test is it should send a message to the SQS and triggers the Lambda. And this is what we're going to implement here. So first of all, we have a queue, right? So once we deploy that, so in this here in the preparation step, we deploy the demo stack. We used in this case listing all the queues using the AWS CLI. And this is why also the endpoint is quite important here, because we list the queues from the local stack, from the Docker container, and then we find all the queues, which is a FIFO. Let me change this, and let's say this is going to be a FIFO queue. So we look for FIFO queues in this case, and then I can also console log the FIFO queue. Okay, and then we send the message to using again the AWS CLI. We have to define like a message here. Let me just copy paste this from my notes. So where we just put a message called hi in here. And now what we expect is we want the Lambda to pick up the message and just log the console or to CloudWatch the message hi. So first of all, we need to wait for the Lambda to be triggered, because otherwise test container is too quick here. So we make an artificial timeout by 5 seconds. And then we use again the AWS CLI to filter log events using the LocalStack Lambda. So this is the log group which will be created when deploying the Lambda on LocalStack, and then we filter to on high. What we then do is we expect that the logs event will be higher than 0, because in this step, we send the message to the queue, and we expect that the Lambda handler is picking up the message, and then we should have an entry with the message hi in here. Okay, so let's go into the LocalStack demo here. And now I'm using a pinned version of LocalStack. I am using 4.11. I know it's not the latest, but yeah, it works. Let's run the tests here. And as you can see, it's logging the URL, which I also put in here, here as an endpoint. It's now doing the bootstrapping. Yeah, you can remove the warning here by turning on the flag here. And so this step is bootstrapping. And then it's creating the LocalStack demo, and it failed. Because the test timeout after 5 seconds. Okay, this because I forgot to put a timeout here at the end for this one test, because I created an artificial timeout by 5,000. Let's run it again. At the same time, what I would like to show you is Docker. You see, I already pulled this image, otherwise we would wait 2 minutes. And if I run this test, it will now create 2 containers. One of the containers is LocalStack, and the other one is the test container itself. So tests are run in the container also. Again, it's now creating the LocalStack demo. We can now see the queue URL here. We also now see that test container was running the test against it. It finds the logs, so that's why it passes the test here. And with that, this is a very simple example, but with that you can really start, okay, how should be the flow starting point? What do I expect here? Lambda is triggered. It writes something into the CloudWatch. I can filter the log message. And yeah, so you can really define your test. And the good thing is all the containers are gone then. The images stays, but the containers are gone. So they are automatically cleaning up. This is all I have for today. I hope you learned something. I hope you also would like to meet Paul. So you can find Paul in my GitHub with my GitHub profile. And yeah, thanks for having me. Thanks for listening.
Awesome. Thanks so much, John. That was fire. We have some questions queued up. Okay, first we're gonna go, how painful is this to add to an existing project that already has a test suite?
I would say nowadays with AI, maybe not so painful as it used to be. Yeah, definitely you need to rethink it. But integration test also differs from unit test. In unit test, you are really testing functionalities, mocking things, where in integration tests, you try to be as realistic as possible. So I would say it's definitely, you need to have a concept. you need to check what tests are there. Can we test against a service such as the database and so on? And then you can roughly plan it out, and then you can let AI do it.
Awesome. Awesome. Okay, that makes sense. I mean, definitely, like if we're not using AI right now, like what are we really doing? So definitely get
Exactly.
that for sure. Okay, so next question. In what scenarios would Paul be a better fit than something like GitHub Actions or a traditional pipeline tool? And where might it fall short, in your opinion?
I'm not sure if I get the question correct, because Paul is not a CI/CD tool. It is a construct library, so it tries to give you coding blocks for your developers so that the developers do not need to think about, oh, did I place that letter Q in there? Do I have the right naming convention? Am I using the latest Lambda? So this is what Paul
Okay.
did.
Okay. All right. So that was a misunderstanding. Got you. Okay. I love the idea of Paul, by the way. Like, and can you please share that? Actually, you know what? We'll share that
Yeah, I will. This will be
link
um,
in.
in my I will put it in my website, and also
Okay.
then share the link with you. Yeah. So this is Paul.
All right.
Uh,
So, you guys, just for clarity, Paul is not anything close to GitHub Actions. Something
yeah.
totally different.
Yeah.
Awesome. All right, next question. What does it do to test speed? Somebody's thinking about that.
Oh, the test speed. Yeah. Integration tests itself are always slower than unit tests, and when I was running it first using against LocalStack, I was always removing the image afterwards. And that means it always cost me 2 minutes to download the LocalStack image and then run the test against it. So it always depends on if you want to run it against like a fully fledged REST API, which you wrap into a Docker container, and that Docker container is, I don't know, 10 gig big, then of course the speed will be much, much, much lower. If you run it um, against something small, uh, let's say a Postgres database where you have not so much, where you also seeded some data in it, but not too much, then I would say it's quite fast. The problem is if you run it in CI/CD, then in CI/CD it may happen that it all the time pulls the image. There you can have like some caching mechanism in place, and also rethink if you want to run it on self-hosted runners instead of using what GitHub Actions, for example, offers you. Um, yeah, there you can think of, maybe I create my own runner and then I apply some caching mechanism on it.
Okay, that makes sense. What about give me a moment where this approach caught something that would have been a production issue, if you have something off the top of your head.
Yeah. So what I saw is for example, now Lambda functions, Node.js 18 is now deprecated.
Mm-hmm.
You are not allowed to deploy, AWS does not allow you to deploy Node runtime Node.js version 18 anymore. It could also be, so that means it prevents you for deploying that, but it also prevents you to have like unencrypted buckets or unencrypted databases. So you can really put in here best practices and patterns to avoid these kind of things. What it's also would prevent you is that you have like different naming convention, because you probably working with different teams and they all have like different ideas of deploying it, or they just dump something which Cloud Code suggested. But with Paul, you have like a unified, you streamline everything. And yeah, this may be helpful for the finance team, that okay, Paul helps you to also give you some tagging and so on.
Very good. Awesome. That is all for that's it for our questions. Thank you so much, John. Thank you for coming. Your presentation was fire. We appreciate that. We love Paul. Definitely gonna go check that out. Because like I think there's so much there that a lot of folks could absolutely use in their workflows. And thanks for everyone who joined and engaged in the chat. We love that. Before we wrap up, quick heads up. We actually just released something new at LocalStack called App Inspector. If you want to learn more about that, check out that QR code. It's basically an observability layer for your local cloud environment, and it lets you see how your services are interacting and catch misconfigurations, debug issues, etc., before you ever deploy to the real cloud. So if today's talk got you thinking about testing against real services, App Inspector is kind of like the next step. So now you can actually see what's happening under the hood while those tests are running. Like I said, you could definitely check that out via the QR code. And if you want to keep the conversation going, definitely join us in the LocalStack Slack channel. That's where people are sharing their setups, asking questions, and helping each other debug all of the things. So that's it for today. Have a great rest of your day wherever you are in the world. Thank you for your time, and we'll see you next month.